Crystallographic separation is based on the interaction of components with both mobile and in both the mobile and stationary phase. It's used to find two things: separation of mixtures and identifying components. The polarity. The stationary phase is less polar. The mobile phase is more polar. The ones in the mobile phase are more polar and migrate faster towards the line. The stationary phase being less polar, therefore moving more slowly. Substances interact weakly with the stationary phase and will spend most of their time in the mobile phase, moving rapidly through the chromatographic system. Okay. First I'm going to place my unknown dot on the TLC. And I'm going to place the TLC into the beaker with the 1-to-1 solution. And I'm going to leave it in there from 10 to 15 minutes. Okay. Here's what here's the one that the solvent went to. I should print for. I think it was left here a little too long, so try not to do that next time. Surface.
Are you ready?
Yeah.
Go ahead and put that on the table.
What?
We should put it on the table. That's what it is.
Yeah.
Okay. So now it's been 10 to 15 minutes. We put our TLC plate in.
Okay, first I'm going to measure the distance that the solvent traveled, which was about 4.1. And then I'm going to measure the distance that the methyl red traveled. It's about 2.9. Then I'm going to divide the distance traveled by the component by the distance traveled by the solvent. My answer is 0.707.
Alright, I'm going to be taking the unknown sample and putting it on my little card with a and I think I might have made a little bit too big of a dot actually, but that's okay because it'll still do what it needs to do. Now I'm going to place my card in my solvent, which is the 15-2, and I'm going to cover it and let it sit for 10 to 15 minutes. And now that our 10 to 15 minutes have elapsed, I'm going to mark the solvent line and circle my solutions. That way, in case they fade or disintegrate, I'll know where they're at. Did I say disintegrate? Alright, now we're going to measure our RF value, which is where we take the distance the solvent traveled and the distance the dye traveled, and divide the distance the dye traveled by the distance the solvent traveled. So, alright, where was I? Okay, so now I'm going to measure at the middle of the bubble, which looks to be about 3.3 centimeters. So I'm going to divide that by the distance my solvent traveled, which is 4.5 centimeters. And I get 0.733 rounding to the third decimal place.
After placing all the known dyes, you place the last dot being your unknown. After you've done that, you place your TLC sheet and your solution, this one being the 1:1:1 ratio, and let it sit for 10 to 15 minutes. After 10 to 15 minutes have elapsed and the dyes have stopped moving, we can move the TLC plate from the solvent and set it down. Now we mark our solution line so that we can see it. Take our retention point and then circle our dyes. So after you've let your TLC plate dry, we now can find the retention point for each of the dyes. Now in the 1:1:1 solution, we find the solvent line, which is around 4.5. Now after we found the solvent line, we measure to the center of the dye mark. Now the center of the first one, which is the methyl red, is around 3.7. The retention point is the center of the center of the dye divided by the solvent line. So we have 3.7 divided by 4.5. And we get around 822.
All of your known dots, you want to take your unknown dot and using the capillary tube, place on the TLC card. And then we're going to take it and put it into the water solution and let it sit for 10 to 15 minutes. So now I'm going to draw my solvent line. And circle each of them so you can show them in case they fade. After the TLC paper. Wait, can we just like...
Just go whenever I want to do.
Alright.
All the
Okay.
noise out.
Okay. After our TLC paper is dried, we are going to find the RF factor, and that is the distance traveled by the component over the distance traveled by the solvent. And to find the distance traveled by the solvent, you measure from the bottom of the paper to the solvent line, which is approximately 5.1. And then I'm going to put that in your notebook. And then you find the distance from the center of the darkest point of each dye. And I'm going to measure fluorescein, which is approximately 0.5. And then so I take 0.5 divided by 5.1, which is...
This one has a lot of space between dots, and so they starting with. It's not as clean as that.
0.098. And that's the RF.
So, ideally, you have